This is part 5 of the wheel video. If you made it this far, you've created a front wheel with 28 spokes. We've done this in a series of 43 steps, with the exceptions of steps 20 through 25 and a few other steps interspersed in the middle here. Steps 20 through 25 are related to the rear wheel, which we will be taking care of in this video. It's now time to change over to the rear wheel configuration by going to the Configurations tab. And when we do so, we see that the entire wheel disappears. Going back to the feature tree, we see the reason for this. All of the features except our original layout sketches from the starter file are suppressed in the rear wheel configuration. So why is this? If we go back to the Configurations tab, look at our rear wheel configuration, go to Properties, down at the bottom under Advanced Options we see that it says to suppress any features that are being added to a configuration that is not the rear wheel configuration. In other words, when we were adding features to the front wheel configuration, they were automatically being suppressed in the rear wheel. This is the default setting. If you know you're going to be adding a whole series of features that should be unsuppressed in multiple configurations, then maybe you should have this unchecked, which is perhaps what we should have done for this wheel project. But for now, we'll just leave this checked and we'll fix the problem that we've created. The easy way to fix this problem is go back to our feature tree. What we're going to do is select all of the features all at one time. So I'm going to hold down my Shift key, left click on step 1, while I'm still holding down the Shift key, scroll down to the bottom, and left click on step 43. And you see how that selects all the features at once. Now I can right click and select the unsuppress icon, and that unsuppresses all of the features that I selected. So that wasn't really so bad. So now we have a rear wheel that looks pretty much like the front wheel with just a few subtle differences. You might recall that the starter file gave you a hub cross-section layout, it gave us a spacer distance of 120 millimeters for the rear wheel and 100 millimeters for the front wheel, and an axle length of 165 millimeters for the rear wheel and 140 millimeters for the front wheel. So if we toggle now between the front and the rear wheel configurations, we'll see that one of the main differences between the two is that the spacers get wider and the axle gets longer in the rear wheel compared to the front wheel. Another item that was set differently in the starter file between the two different configurations was the angle of the spokes in the spoke layout sketch. For the front wheel, it was assumed there would be 28 spokes, so this angle for the spokes was set at 25.7 whatever degrees, and for the rear wheel it was assumed that there would be 36 spokes, and the proper spoke angle in that case was 20 degrees. Toggling the configurations shows that the spokes change their angles between the front and rear wheel, but there are still 28 spokes in both configurations. On the rear wheel, what you notice is that the spacing of the spokes around the perimeter is no longer even like it was on the front wheel. Here we have a wide space, a narrow, a wide, and then a very wide space. Because of all this, the hole pattern for the spoke holes going around the rim, as you can see when I highlight it, is not matching up with all the spokes either. Some of the spokes are misaligned with their holes. We will be fixing these sort of problems at the end of this video. If we take a look at our completed example file, we see one of the primary differences between the front and the rear wheel is the front wheel has a very simple revolved shape covering the bearing area. The toggling to the rear wheel config, we see a much more complicated situation where we still have bearings contained in this area of the hub, but we also have screw threads here in here, which are used for screwing on a lock ring on the smaller set of threads and the sprocket on the larger set of threads. Here we see a completed rear wheel with the sprocket and the lock ring attached. If I take a cross section, you can see a little more easily what's going on. Here's the area that we're going to be building on the rear wheel hub that has the threads, the lock ring, and the area that has the threads for the sprocket. There's also a shoulder here that the sprocket sits against once it's tightened. You'll also notice that we of course have threads on the other side of the wheel, which doesn't seem to make sense because the chain is going to engage the sprocket on this side of the wheel. This type of hub allows for the option of a second sprocket of a different size or type to be put on this side of the wheel, so that, for example, if you're needing to climb a hill or something like that, you can have a larger sprocket on this side. You can flip the wheel around and engage this sprocket instead. The reason I chose this type of wheel is because it's perfectly symmetrical and makes this project a little bit easier. The threads you will be creating, of course, will not be visible on this side once they are covered by the sprocket and the lock ring, but they will be visible on this side. So if you're doing some renders later on this project, you'll have a little bit of visual interest added by all these details that we've put into the model. Getting back to the wheel file we were actually working on, what we need to do is roll our rollback bar up just after the features that were used to create the bearing area for the front wheel. So we're going to roll up just after step 19. Now we see we're back to a very bare bones wheel that's just a couple of spokes, the hub, and this bearing area. We can't use this feature for the rear wheel, so what we will do is go ahead and suppress that. That's step 17, and when we suppress it, what we see is steps 18 and 19, which were fillets added to this bearing area, are automatically suppressed at the same time because the feature that they were attached to at the moment does not exist. Now let's go ahead and turn on our hub section layout sketch and our sprocket threads layout sketch. And let's take a look at them from the view of the right plane. Here we see the axle, the spacer, the threaded area for the lock ring, and the threaded area for the sprocket, and that shoulder that the sprocket tightens against. What we are going to do is make a revolve feature that includes these three areas, but we are going to do it without the screw threads, and later on glue the threads on to the cylinder that's formed here and a cylinder that's formed here. So we are now ready to do step 20. We will start a new sketch on the right plane and start copying the appropriate lines using convert entities. I'm going to copy this line, this line, this line. You might think we're going to copy this line and this line, but instead what we want to do is copy the line that represents the base of the thread, because we're going to make a smaller cylinder and then add the screw thread onto it. So we'll copy this line and this line, not this or this line here, and this line here. So let's take a look at what we've got. Let's hide everything. Then what we want to do, stretch this line out here, stretch this line out here. We'll add a new line going from the origin out and start trimming away the excess bits. Finally, this line here, let's tilt this so we can see what we've got. And I'll turn off my relations to make that a little clearer. Here's the shoulder. Here's what will be the threaded area for the sprocket and what will be the threaded area for the lock ring. Revolve about this line. And that completes step 20. Step 21 will be to make a single screw thread on this smaller cylinder. So going back to our right plane, start a new sketch. Let's view this from the right. And turn our sketches back on. What we want to do is just copy these 3 lines which represent the screw thread in this area. So again, going to Convert Entities. Then backing away here and adding a center line at the origin, going horizontal. See just that small little screw thread. We will revolve about this. There's our first screw thread. That's step 21. Step 22 is to take this screw thread and pattern it in this direction. We'll use axis 1 as our pattern direction. So going to Pattern, select axis 1. I grabbed the wrong thing here. Select axis 1. And then for the feature we are going to pattern, this time we're patterning a feature, not a body, will be the screw thread. You see the highlight here, the threads are too far apart. Now this screw thread is 24 threads per inch. That's going to set our distance here. So we're going to let SOLIDWORKS do the math. We're going to just type in 1 inch divided by 24. That way we don't have to calculate the spacing. That converts it to metric and gives us the proper dimension, which I will not read out here due to the decimal places. Now we see we've got way too many threads. Let's start out with about 3 threads and add to it. So 3, 4, 5. And I'm going to stop there because this is going to be a machined hub. And when you're machining threads onto something like this, usually the last thread is hard to get into place and there's a little gap left in place here. So we will purposely leave that gap there. We can see just a little remnant of the original cylinder that we had built. Steps 24 and 25 are just more of the same. So on the right plane we'll make a new sketch, and this time we are going to copy these 3 lines for these threads. Convert Entities, zoom out and make a center line and revolve feature. Again, we are going to pattern these threads. Direction we will use is axis 1. The feature we will pattern is this thread. It's going the wrong way, so I'll flip the direction. We still have the distance left from the original pattern. This distance is the same distance we want to use for this thread. 5 threads is about right. So we'll finish this. And here we see again we have a little bit of a remnant of the original cylinder. That's okay. So we got enough room for 5 threads on both cylinders. That completes step 24, and step 25 is very simple. It's just simply a 1 millimeter fillet added between the shoulder and this flange. So now we have steps 20 through 25. We're going to go ahead and roll forward to step 26. We see that hole that we added originally in the front configuration to go through the hub. Now we purposely drew the sketch for this so that it was well wide of the hub, so even though the rear hub is wider than the front hub, this hole still manages to go all the way through in both configurations. Now if we roll forward again to step 27, we see that step 27, which was the edge of the hole in the front wheel configuration, is now suppressed. This is because the features that that fillet was attached to are suppressed as well. What we have to do is make a fillet that is only going to be used for the rear wheel. So we will add a 0.5 millimeter fillet to this edge, and that will be our step 28, which is interleaved between 27 and a previously made step 29. Continuing to roll forward, it looks like there are no more features that need to be added to our rear wheel. I think all of the different numbers here are covered from 1 to 43. And here we see our completed rear hub with all the spokes and the appropriate length spacers and the appropriate length axle. One nice thing is that because we mirrored everything as bodies rather than individual features, it turns out the mirror command then when we use either the front wheel or the rear wheel is always going to mirror the appropriate shapes and features to the other side. So we didn't have to do anything consciously to make sure that on the rear wheel that this side was a perfect mirror of this side and had all of the related features to it. All this happened automatically for us. Now, although it looks like this wheel is complete, we already know ahead of time that there are a few things that aren't quite correct. For example, the issue of the spokes not being properly spaced and the holes not being properly spaced, and also we know that we don't have the proper number of spokes at the moment for the rear wheel. Step 29 sets the number of spokes or instances that are supposed to be copied when we start with our 2 separate spokes and then make our full complement of spokes on one side. The number of instances that we have to make for step 29 was a total number of spokes divided by 4. Right now it's set at 7, which will give us 28 spokes. We need to set this to 9 in order to give us 36 spokes. The problem is if we change that number right here in the feature manager, it's also going to change the number for the front wheel configuration. We want to leave it for 7 in the front and have it be 9 for the rear. So let's go ahead and close this. And we don't actually have to be rolled back. I just did that to demonstrate what this area looked like. I'll just go ahead and roll forward again. I'm going to highlight step 29. If we zoom in, we see the parameters related to step 29. 7 instances revolved around 360 degrees. This number we need to change. This is a little tricky. Sometimes it doesn't work right unless you click very rapidly, a double click with your left mouse button. If you do it right, you'll get the modify box coming up. If you don't do it right, if you click very slowly, you end up getting this type of box that only allows you to change the number. You need to have this modify box. See, now I can't even get it to do right. You need to have this modify box. What this allows you to do is select the configurations that you're going to change the number for. Here we have the symbol that right now is set to all configurations. We need to change this to this configuration, and then we change this to a 9 and hit the check mark and then hit rebuild. Now we have 36 spokes in this wheel, and it should only be for the rear wheel. So we have 36 spokes in this configuration, which means that we need to have 36 holes in the rim as well. So again, highlighting this in the feature tree, because this is a pattern, it now also highlights at the center of the pattern the number of instances and the total angle they're patterned about. We need to change the 28 to 36, so double click rapidly to get the modify box. Change this to 36 and make sure that this is set to this configuration. Rebuild. Let's zoom back out. re-highlight, and we have 36 holes, but we still notice that some of them are not aligning properly, and then we start to notice that even though we have the proper number of spokes now, the spokes still are not evenly spaced. And the reason for this is that we have to change one last thing. We have to change the amount that this side of the wheel is twisted with respect to this side of the wheel. That amount of twist is dependent upon the total number of spokes in the wheel. And since we've changed the total number of spokes, we have to change the total angle of twist. You'll recall that was done using step 31A. I'll just skip back to 30. What we did was we used the move copy command to take this half of the wheel and rotate it in order to get the spokes to interleave. There's one problem though, is if I click on this feature, there are no parameters that highlight that I can change for the rear wheel. This is one feature that for whatever reason in SOLIDWORKS cannot be changed with configurations. So our only recourse then is to suppress this feature for the rear wheel and create a new feature that will only be used for the rear wheel. We're going to twist this again with a brand new feature on axis 1. So we're going to say Insert, Features, Move/Copy. Make sure that this menu is up, not the one with mate settings. The body we're going to move is the second body like before. We're going to rotate it about axis 1, and we have to decide what is the appropriate angle. The angle is 360 divided by the total spokes. We have 36 spokes, which we divide into 360, so that gives us an angle of 10 degrees. Now we see that these are perfectly interleaving with the same spacing at the perimeter. This then is step 31B in your example file. Rolling forward to the end of the feature tree now. Take a look at the spokes and the relationship. To the hole pattern, and we see that all the spokes now, the tips of the spokes, all align with the hole pattern in the rim. Another thing that perfectly aligns is the hole for the valve stem. I built the sketches in such a way that if we have all of our parameters set properly, this hole will always be properly spaced between these two spokes. I think we finally have a complete front and rear wheel, but let's go ahead and toggle between the two configurations and make sure everything looks good. So here's our rear wheel. I'll zoom in just a little bit. Here's our front wheel. And let's take a look at the feature tree and make sure that nothing is suppressed that shouldn't be suppressed. These are suppressed for the rear wheel. This is suppressed for the rear wheel, as is this, and everything else looks correct to me. So I think we've successfully built, with one part and two configurations, a front and a rear bicycle wheel. The next video will show some ways that we can even further customize the pattern of spokes here, especially if you want to have a wheel that has fewer than 28 or 24 spokes, which creates some unique problems.